So this is an introduction to standard form. Standard form is a way of writing really small numbers in a nicer way to look at them and really large numbers in a nicer way to look at them. So you kind of understand what numbers are going on and also the size of them. So before we start, I need to reteach you about reciprocals. Now, if you're not sure about reciprocals, I'm going to do a quick explanation now, but there's also another video under the indices playlist that you can watch as well. So basically, a reciprocal is the inverse of a normal power. So for instance, 10 squared is 10 times 10, which equals 100. But 10 to the negative 2, rather than positive 2, is 1 over 100. When you see a negative sign on an index, that means it's the reciprocal or the opposite of it, and I'm going to show you why now. If you have 10 to the negative 2, that means that you have 10 squared flipped upside down. When we write 10 squared out normally, it's 100. Now, any whole number that you see is really a fraction over 1, because any object divided, that's what the line on a fraction tells you, by 1, so 100 divided by 1 equals itself. So any whole number is really a fraction over 1. Now, the reciprocal, we know we need to calculate this, so this is 10 squared at the moment. The reciprocal makes us flip it upside down to make it the opposite of it. So when we see 100, we write it as 100 over 1 in a fraction, and that allows us then to flip it up the other way round. So actually 10 to the minus 2 is 1 over 100. So that's the reciprocal. Now this is why reciprocals are important. So if you times by 100, that will give you something 100 times larger, so 700. But if you times by the reciprocal of 100, which is 1 over 100, that's essentially saying that you're doing 7 over 100. If we multiplied these two together, 7 again is a whole number. If we wrote that as 1, as a fraction, we'd write 7 over 1. Now notice when we multiply fractions, if you can remember from when I covered fractions with you, so we times the top two numbers together and the bottom two numbers together separately, so you end up with 7 over 100. Now, if we work out 7 divided by 100, we end up with 0.07. So you can see here that the reciprocal gives you the opposite direction. Timesing by a whole number makes it bigger, but timesing by a number less than 1, or the reciprocal of your original whole number, makes the object get smaller. So for example here, what this really means is I've got 10 to the 7, 1, 2, 3, 4, 5, 6, 7 zeros, under 1, times by 5.5, because I've got 10 to the 7, but the reciprocal of it, because it's negative, it's a negative power, so I have to flip it upside down. Now notice, if I times my two objects together, I'm going to times 5.5 by 1, which gives me 5.5, and then 1 times 10 to the 7, which would be 10 million, really means 5.5 divided by 10 million. Now, if we write this out normally, we're going to pull our numbers backwards. So we're going to pull our numbers this way because they're going to get smaller. Just checking I've written the right amount of zeros. No, I haven't. Okay. So for instance, at the moment, our decimal place is here, but this 5 is going to be pulled back 7 places. So at the moment, I've got my decimal point here and my 5 is sitting here, but it's got to go back 1, 2, 3, 4, 5, 6, 7 places. So if it started here, 1, 2, 3, 4, 5, 6, 7 places, and then this 5 is going to keep sitting behind it. Now notice that we've got all these gaps, so we need to fill them in with zeros. So our answer to this one, if we were writing it from standard form into normal form as a decimal, this number, so 5.5 times 10 to the minus 7 is 0.000005. So notice when you have a negative power of 10, your number's going to get smaller because essentially that means that you're dividing the number that you've been given by 10 to the 7. So let's have a look at this one. We've got 9.63 times 10 to the 9. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So this means that this number is going to be pushed forwards by 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So at the moment I've got 9.63, but my 9 is going to be pushed forwards by 9 places. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So my 9 is now going to sit here. My 6 is going to follow it. My 3 is going to follow that 6. And then the rest of the gaps we're going to fill in with zeros. Now notice that the 9 started here, so we need to put a 0 here as well. Now one way you can double check it is however many numbers are moving from behind your decimal place, so here I've got 2, those 2 will cancel out the positions of 2 10s. So I know that I end up with 1, 2, 3, 4, 5, 6, 7 zeros in front of my 9. So let's check it. 1, 2, 3, 4, 5, 6, 7. Perfect. So 9.63 times 10 to the 9 equals 96300000000. So that's your answer. So here is something I see quite often that people do wrong. They'll write 16.10 to the 5. Now this is not in correct standard form because your first number that you write must be between 1 and 9.9 recurring. So here actually 16 is bigger than 9.9 recurring, so I need to change it to 1.6. So actually what I've done here is I've divided by 10 to make sure that it fits in between 1 and 9.9. The problem is people then forget and just write 10 to the 5 and keep it the same. But the thing you have to remember is whatever you do to this side, you have to undo at the other side to make sure that they keep in the same relationship. So for instance here, because I've got 10 to the 5 and I have to times by 10 to undo my divide by 10, I have to increase this power by 1 because I'm timesing by another power of 10. So let's check this. We divided by 10 to get to 1.6 because we needed our starting number to be between 1 and 9.9. And because we've divided by 10, we need to times by 10 this side to make up for it. So let's check to see if this comes out the same as this. So if I have 16 times 10 to the 5, I have 1, 2, 3, 4, 5 zeros because 10 times 10 is 100, which is times 10, which is 1,000, 10,000, 100,000. So I'd end up with 16, 1, 2, 3, 4, 5. Now let's try this. If I have 1.6 times 10, okay, I have to move one number from a decimal to a unit. So that means I need 1 power of 10 used up to get it over here. So now I have 1, 2, 3, 4, 5 zeros to find a home for. So really, when I have my 6 here, I'm going to end up with 16 and my decimal point here. And then all of my numbers still need to move up by 1, 2, 3, 4, 5 places. Sorry, it's a bit wiggly. So this one is going to go here, 1, 2, 3, 4, 5. So I'm going to have 1, 6, and then all of the gaps need to be filled in. 1, 2, 3, 4, 5. I counted that wrong. And the other one. Okay. So I end up with So I've got 3. That's 1,000. That's 10,000. That's 100,000. So I have 1.6 million essentially.